Hi, I'm Professor Daryl, and I'm going to go ahead and talk about how stars die, because that's the kind of most interesting aspect of astronomy. Stars live by simply fusing hydrogen or helium, and that's basically the end of it. It does that for millions and billions of years, depending on the type of star it is, and then it dies. The death process, though, is the most interesting part. So we're going to talk about the death part, and I'm going to try to simplify it because there's really a pattern between the death of a low mass star and the death of a high mass star. One little key difference though. So let's talk about that. Well, as you may know, gravity likes to contract things, and when things contract, they get hot. So in the first bit of the protostar, gravity contracts hydrogen in the stellar nebula. It gets hot, it starts to fuse. The star lives for a very long time. When the hydrogen turns into helium, just like the natural order of things, dense objects and higher elements like to go towards the center, and low dense and lighter elements like to go towards the shell. Eventually, as the hydrogen turns into helium, you're going to have a dense helium core, and all the hydrogen that's used for fuel as the star initially will tend to go towards the outer shell. Well, if that's the case, the shell is going to start fusing, and because there's nothing really pushing it down, it's going to start to get bigger and bigger. And that's when the star turns to a red giant, because of that huge hydrogen shell expanding to that thermal pressure. At the same time, the newly formed helium core is going to get smaller and smaller because helium is not fusing yet. Well, as the hydrogen shell expands and the helium core contracts, gravity is going to obviously contract it. And when it contracts, it's going to get hotter. Well, in a low mass star, eventually that helium core is going to start to fuse. And that's what we call in a way, the second life of the star, or the helium flash. And that's when the star undergoes a supernova explosion, and it kind of lives for a little bit longer. Well, eventually in the low mass star, that helium is going to turn into carbon. And so you're going to then have a carbon core. The helium is going to make its way out to the inner shell, and then you're going to still have that hydrogen outer shell. Well, the core is then going to start contracting while the shell is going to start expanding again, thus turning the star into a red giant. In this case, more like a red supergiant, or a bigger version of the red giant. Well, that's the end of it. Once that low mass star turns everything or most things into carbon, and you got that shell just evaporating away, the star is dead. You got the white dwarf, and you got the stellar nebula going off into outer space. Now, as you can see a little later in the lecture, a high mass star undergoes pretty much the exact same thing. Undergoes the exact same thing. The difference is that it does it more times. So let's start off with a high mass star having a carbon core and a hydrogen helium shell. Well, the difference between a low mass star and a high mass star is that a low mass star does not have the mass to fuse carbon, but a high mass star does. So you got that carbon core getting smaller and smaller due to the immense force of gravity, and eventually it's going to start fusing due to the immense heat. Once carbon starts to fuse, it will then have another life for that large star. It will kind of drift back to the main sequence. And eventually, in actually a short period of time, the carbon is going to turn into oxygen due to the helium influx from the inner shell. So now you have a oxygen core, a carbon inner shell, a helium middle shell, and a hydrogen outer shell. The oxygen core is going to start contracting, and the carbon, helium, hydrogen shell is going to get bigger, thus creating a supergiant. Okay, well then eventually the oxygen is going to start contracting, and is then going to start fusing into a higher order element. Now, the list of elements that it fuses to is on my lecture slides, and you should be able to see it. Essentially, it goes from oxygen to neon to magnesium to sulfur to silicon and then iron, just through the combination of atoms within the core and the shells. So it's all the same song and dance no matter what you do. You got the inner core contracting, the outer shells expanding, and then once the inner core starts expanding, the shells are going to then contract. And it's just going to happen over and over again until you either have a carbon core for a low mass star or an iron core for a high mass star. And that's the end of it. That's essentially the pattern of how stars die.